Hello, everyone, and welcome back to Programming with MrZemo. And today, guys, I will be teaching you how to use an ultrasonic distance sensor. Um, I would be feel glad if nothing happened. Now, without further ado, let shall begin programming.
The assembling process. Now, we are going to need this guy, ultrasonic distance sensors, and this is an ultrasonic distance sensor, and it is a HC-SR04, the sensor we are going to use today. Its placing is quite important. These two eyes should not see anything other than the target you want it to see. So like, don't make it this way. Don't interfere to its vision by cables. Be extremely careful about that. As always, LEDs, 3 of them. Cables, regular ones. We don't need to use those finicky different ones. Just the regular ones we need today. So, as always, start with 5 volts and ground pins. Send them straight to here. This lines. As always, nothing different today. And LEDs. In order, I place them in this order: red, green, and blue, to resemble RGB LEDs. In other words, pixels. Yes. You may remember the video I was trying to make controlling an LCD LED's light intensity / color via using potentiometers. Unfortunately, my RGB LED did not work, so I have to change the video. That type of thing. Okay, the LED cables, just pretty simple and straightforward. 9, 10, 11. Blue goes to 11, green goes to 10, and red goes to 9. Pretty simple and straightforward. Now, this is the important part. Or a distance sensor, HC-SR04, is the one. It is the important one. So, 2 outputs. I will put it on the screen right now. Ground pin. Let me just show it to you also this way. VCC voltage. This VCC is voltage in. Trig is when we go out when it sends waves. Echo is when this one of them reads. I don't know. Yes, this one is the one reading, and this one with the mark T is transmitter. It sends out signals to see an object, and the receiver receives that signals, reflecting signals from it, so it can understand what is the distance. Echo is the one we use for receiver. Trig is the one we use for transmitter. Ground for ground. Nothing too advanced. So this is quite important. Ground pin goes to ground, but be extremely careful where you plug them. These should not interfere the eyes of the sensor. It should not interfere any. Be extremely careful where you plug these guys. Okay. Now I have orange and yellow. You can use any other color. As I said many times before during this programming adventure, the color does not mean anything. Trig pin goes to 7, and wait, are you going to do this to me? trig pin goes to 7. Finally did it. And echo pin goes to 8. Digital port 8, digital port 7. Now these ground cables form our LEDs. Nothing too complicated. Unlike the potentiometer one, it was just a mess. It was a huge mess, wasn't it? And it is done. Our assembling process is complete. Let me make a tour of these. So, sensor here, LEDs, just as always. Let me adjust the light a little bit. Nice. The cables, nothing too actually complicated, just any good old circuit. That's it. And let's shall begin coding or programming. Yes, programming, because it's programming with MrZemo. And let's shall continue on programming.
The programming. Now, as always, we're just going to start with integer led red as 9, not 0, 9. Integer led green as 10. Integer led blue led blue as 11. Now, for when it comes to ultrasonic distance sensors, there are 4 integers we have to define. 1. Integer trig pin. This is just the thing we use to send signals. Trig pin is 7. And integer echo pin is 8. Nothing too overcomplicated here, but now it is important. Int time. I will explain. Integer distance. Distance is this in short. Probably it has a different name, but I decided to make it this. Okay, so I will explain what dist and time will be used, because time makes no sense for you, most probably. So, void setup, pin mode, led red outputs. I will just go ahead and copy paste this part to make the video not so long, but please do not copy and paste inputs. And this is echo pin. Okay, led red output, led green outputs, led blue outputs, and trig pin is also output. Now, why echo pin is an input, you may ask? Echo pin is an input because we receive signals from it. The trig pin is the one we give out signals. We send signals, and the echo pin catches the signals which are echoed. Yes, echo. That's basically it. So that's why we have to set trig pin output, because we are giving signal, and echo pin is input because we read signals. Okay, so you have to make this part like this. There's no way around it. This part I'm going to start typing is a fixed part. You can't replace it and by any means. Okay, you can't even change the high to 1 or 0, low to 0. It is fixed one. There's no way around it. Okay, digital right trig pin low. You can't use 0 here. This is a fixed part. This is fixed. There's no way around it. And delay microseconds. Microsecond is extremely small second. It would not make any difference in real life, but for sensors, even a microsecond is important. delay microseconds 2, digital right, trig pin. Why I keep typing trig as it like this? Trig pin high. Delay microseconds yet again 10, and digital writes trig pin as low. Okay, explain. Let me just explain. We stop giving out signals for after 2 microseconds. We start sending signals. After 10 microseconds, we stop it. This is a fixed part. You can't question it. There's no way around writing anything other than this. It's a fixed part. Now, this is extremely important. Time is equal to pulse in echo pin high. So time is pulse in reads how much time did echo pin spend reading here. Time is how much time echo pin spent reading information. High means getting information for echo pin. In paper this should work, but since we define echo pin as input, it should not work in mind. But this echo pin high means time when it received signals. So high is when the time it got signals, and low would be to time it wouldn't got signals. So it will not make sense. Now, this is also important. Distance is equal to time divided by 2 divided by 29.1. So 29.1 is the speed of sound here, and 2 is for fun. Like, don't question it. It is a fixed and it cannot be changed. I don't know why we divided by 2 here though. To eliminate, yeah, I think it's because the time spent sending and receiving is 2, so we have to divide it by 2. I think that's the reason why we use, but that's the reason why we divide it in half. Okay, so this delay is optional, but I'm going to write it here. Delay 500, a half a second. So this part is fixed. You can't change anything about it. It is how it is. Digital write, trig pin low. We stop sending signals. After 2 microseconds, we start sending out signals. After 10 microseconds, we stop. And time is how much time did echo pin work? How much time did it read signals? And distance is the time divided by 2, so that it counts as only one go, and divided by the speed of sound, and we will get the distance. If I could not explain it, please let me know in the comment section to paraphrase it, if you did not understand, of course. So the logic part, main code is done. It's just a simple logic. If distance is lesser than 10 centimeters. Yes, these are centimeters, I think. At least we told them centimeters. So we just go ahead and use distance is lower. If the distance is lower than 10 centimeters, digital, right? LED R1. You can change 1 with high if you want to go with the fancy way of doing so. Digital, right? LED green, low or 0 in this case, and digital right, LED blue, 0. So if the distance is lesser than 10 centimeters, the only LED that's on should be the red LED, and the rest should be turned off. So this part is important. Be careful. If distance is greater than 10, and this tube means and, as I mentioned in the simple logic episode, this means and the distance is lesser than 20 centimeters. Only turn on the LED green. This is important. You have to write it this way, otherwise it's not going to work. If distance is greater than 10 and if distance is lesser than 20, 12, not 20. Well, no, 20. Oh my god. I'm a bit too tired for it. 20. Yeah, 20. 20. Yes. If the distance is lesser than 20 and how did I... Okay. If distance is greater than 10 and lesser than 20, only LED that should be turned on should be the green LED. Now, this part is also important. If distance is greater than, well, 20, I think I'm going to have a huge cup of coffee because I could not sleep last night. If distance is greater than 12, 20, oh my god, like, it's killing me. If the distance is greater than 20, only LED that should be turned on should be blue LED. And in theory, our program is complete and should be working. Now, all we gotta do is specify which board and which pin are we going to use it on. Select initiation 3, Uno, and send the program. Oh, troubleshooting, and as it turns out, 10 and 20 centimeters is a huge distance. Can't be portrayed by my camera, so I will just go ahead and turn them a little bit down so it is easier to see. But you can read distances from 0 to 255. It should be working. Troubleshooting. If it's working, nice. Red. Can I get... Oh. Nothing happened. Don't need to freak out. Okay, red, green, and blue. Okay, nice. So, I will turn on the camera right about now.
This is our distance sensor. If it is too close, we get a red light, not a green one, red lights. I think I'm better off using a book. Wait a second, I will be back. I am back with a notebook, a little grey notebook. It's actually a little bit camera since it has the longest. So, distance, red. The closest is red. Let me show it to you again. The closest is red. We go a little bit further, about 7 centimeters, and we will get green one. And anything about it is blue. Let me show it to you again. Green and red. Okay. So a little talk before I turn off the recording. So friends, we almost hit 30 subscribers. I think as I'm recording this, I have 29. Please go ahead and subscribe, please, if you're not. So, the recent stuff that is happening in my life is that two weeks after this, the marathon of exams will start. So 2 weeks after this video is recorded and posted, I won't be making any new videos, but that does not mean that I won't post. No promises, but I may be able to post videos because I can just pre-record them and upload them when the time has come. I think I will record the videos this weekend, and yeah, that's basically it. And also, I don't know how do I put this, but we have a little MUN conference coming this Thursday, so I have to make some research about it. If you don't know what MUN is, go figure out by yourself, because it will take an hour if I try to explain it to you guys. And that's it basically. So yeah, thank you everyone for watching us struggle through the ultrasonic distance sensors, and by no means it is no hard. Trust me, all you gotta do is just try to understand how the sensors work. And yeah, that is basically it, friends. And thank you everyone for watching and bearing my horrible English. So don't forget to like and subscribe and share the video if possible, because I need money. Money is life. Money speaks. Money talks, they say. I'm just I recently learned that I can speak extremely fast, so I decided to try it, but I shouldn't have done it. Okay, please do not forget to like and subscribe and share the video if it's possible. We have almost hit 30 subscribers, and I have to thank you guys for your amazing support. Please watch my videos actively because I need money. Money talks. See ya.